So let's continue doing that. So this is very important. We're limiting our definition and discussion to unity feedback systems. Okay, and the expressions we have derived, the expressions we have looked at are specifically for unity feedback systems. And what did you look at is steady state error. We use E in parentheses infinity. This denotes the steady state error is equal to limit as s tends to 0. Okay. S R of s equals 1 plus g. Now we looked at an example last time, and we also figured out how to compute steady state error for different kinds of systems.
Yes, as unity.
Unity feedback system. Okay. Consider these systems. Okay. One. So consider these three systems. This system is a type 0 system. This is type 1 system. And this is type 2 system. Okay. And this definition, type 1, type 0, type 1, type 2, is based on how many pure integrators are there. Okay? What does that mean? If you look at the system, so try to answer this question. How many pure 1 over S terms are in 1, 2, and 3? Okay. How many pure 1 over S terms are in this?
0.
0, right? So that is the reason it is a type 0 system. Here you will see that there is one pure 1 over S term. Okay, so that's the reason this is a type 1 system. This is a type 2 system. Okay. Now if you see, if this is your type 0 system, okay, for type 0, E step is equal to what? E step would be S. So here let's do this S into 1 over S divided by, put the limit. Limit and reference to 0 is S 1 over S 1 plus 120 S plus 2 S plus 3 S plus 2. So this is equal to 1 over 1 plus 120 multiplied by 2, 3 into 4, which is 10. 1 over 20. Okay. For type, if you look at the RAM, it will be infinity. Okay. Because you'll have S 1 over S square divided by 1 plus 10 into 2, 3. So what will happen is this will be 1 over S into all of this. When this S goes to 0, this will be infinite.
What is the step
Hmm?
and
Step input. So R of S here, it means R of S is 1 over S. Okay. Here R of S is 1 over S square. and E parabolic would also be equal to 1 infinity. Okay, here R of S is equal to 1 over S cube. Now you see this pattern. If I look at for type 1, each step would be 0. E ramp would be finite, and E parabolic would be infinite. And again, to continue this discussion for type 2, each step would be 0. E ramp would be 0, and E parabolic would be finite. When I say finite, I mean just a finite value. Here it is finite. Okay. So you see, for each of these system types, there is only one input which will yield a finite steady state error. Okay. With exam point of view, what you need to know is, you'll be given, let's say, find the steady state error, and the input will not be given. Then what are you going to do? Based on, you have to determine what the system type is, and accordingly use the appropriate input.
Question.
See the number.
Alright, let's take a look at an example. Okay. What example is what? this system, you have C of S. Question would be, find the value of K so that there is a 10% steady state error. You have a now this is all the question is, right? So where do you start? Again, you go back to your basic definition of steady state error, which you'll have to use again and again. E infinity is limit as s tends to 0, s r of s divided by 1 plus 0. Okay? Is the value of r of s given to you? Or what is r of s here? Hmm? What type of system is this?
Oh, that's a feedback system.
Look at that table. What type of system is it? Is it a type 0, type 1 or type 2? What? Huh? Go back to your notes and look at your notes.
Type 1.
It's a type 1 system, right? So if you look at type 1 system, it cannot be this. It cannot be a step input, because what is type 1 system? What is a steady state error for step input? 0, right? It has to be this ramp input. Okay? So this is how you determine that. So it cannot be parabolic input or step input. It has to be ramp input. Only one of them will satisfy. So if you look at that S, there is one pure integration term. This is called a pure integration or pure 1 over S term. Okay, 1 over S is an integrator. So what you do is, what is this E infinity? E infinity itself is 0.1, 10%. Okay? So you have limit S tends to 0, S, R of S is 1 over S square over 1 plus K S plus 5 divided by S into S plus 6, S plus 7, S plus 8.
So did you determine that it was E rank? That it was E rank like based on the type, or did you determine the R's first? I'm kind of confused on it.
He determined the type first. And
Yeah, I understand. Okay, the type, then what was after the type?
then he looked at those three. And I think that your question is, why did you pick finite out of the other two?
Well, no, but that's a question.
What is your question again?
What did you do after you determined the type?
So you know, once you know the type, you look at which steady state error, for each type there is only one steady state error which is finite, right? Which is for type 2, for type 0, what steady state error is finite?
Sister.
Huh? The step. For type 1, what steady state error is finite?
So you're looking for the finite.
It has to be finite, right? This 10% is finite. 10% is not 0. 10% is not infinity. 10% is not 0. 10% is not 0. 10% is not infinity. 10% is not infinity. So it has to be either this, or this. But if you look at what type of system it is, this is type 1 system because there is only one pure 1 over S. Okay, so you have to, the only input here for which there is a finite steady state error has to be a ramp input, right? Which means the steady state error is a ramp steady state error, E ramp. Okay, so you can still stick to the basic definition of steady state error. You don't have to remember the specific definition for E ramp. You remember this and you substitute R of S is equal to ramp input 1 over S square. Okay, now you get this. What will happen here is we'll go with this. Okay, so you have limit S tends to 0, 1 divided by S plus K into S plus 5 divided by S plus 6, S plus 7, S plus 8. Okay, so this will be 1 over K into 5 divided by 6 into 7 multiplied by 8. This is equal to 0.1. So what is the value of K from this? K would be 672.
What happened to the S's?
So you evaluate this. That is what it means. A limit you have evaluate at S equal to 0.
So the K value of 672 will give you a 10% error.
He'll give you a 10% error for a step input. What will be the steady state error for a step input?
What will be steady state error?
So now.
For this system, if there is a step input, what steady state error will it yield?
10%.
Huh?
10%.
It will yield 0.
What?
What was that question one time?
For this system, if the input is a step input, what is the steady state error?
Say if it's a step input.
What is the steady state error?
4 times.
Huh?
The same 4 type 1 is the error for step input.
Regardless of what the poles and zeros are of the system, if the system type is type 1, for any type 1 system, the steady state error for a step input is 0. What is the steady state error for a parabolic input for a type 1 system? Infinite. Okay. So it will, regardless of what the poles and zeros are. What are the poles here?
-6, -7,
And
0.
0. So -6, 0, -6, -7, -8. Right? And what are the zeros? -5. So regardless of what poles and zeros are, if it's a type 1 system, the only finite input will be because of a ramp input. Okay? And this is how you calculate. So if I give you a trick question, calculate the steady state error for a type 1 system given that the input is step input. You should just hit 3.
That's a good question.
Okay.
Yeah.
Seems to be a good stuff.
Alright, so we'll stop here. We'll complete this chapter next time. I have uploaded your fourth assignment. It will, your exam 1, which is scheduled for April 1st, will be on chapter 6 and 7. Okay? It will be stability and steady state error. And assignment 4 will also be on stability and steady state error. So during the week you'll get some questions on steady state error. So just be prepared for that.
So right now,
Huh? Project I'll upload it to.
so right now the assignment just consists